All right, let's go over sp2 hybridization using ethylene, which is C2H4. All right, if you draw the Lewis structure for ethylene, it'll look like this. And the question is, what do the bonds look like for all these bonds in ethylene? All right, so let's take a closer look at one of the central carbons. Okay, so carbon has 6 electrons. Let's just draw the energy diagram for that carbon on the central carbon on the left. All right, so carbon, it's going to have 2 electrons in the 1s orbital, 2 electrons in the 2s orbital, and then it's going to have 2 more electrons, and we'll put them in the 2p orbitals. All right, so the question is, how can we, because we know through VSEPR, right, the bond angle here, the central carbon has 3 electron domains, or 3 effective pairs. So whenever the central atom has 3 effective pairs or 3 electron domains, is the bond angle there around there is going to be 120. So that's 120. They're all 120. And so again, there's no, just like in our sp3 video, there's no way you can combine an S and any combination of P's and get 120-degree bond angles, because S orbitals are spherical, and then the p orbitals have to go along the x-axis, the y-axis, and the z-axis, and there's no way, like, these are all going to be 90-degree or perpendicular from each other, so there's no combination that will give you 120. So that's the problem. So we need to hybridize or mix these orbitals. So we need to mix, let's just do focus on the valence electrons. We need to mix these in a way. All right, so here's what's important to remember. When you need a central atom with 3 effective pairs, or 3 electron domains, then you're going to need sp2 hybridization. All right, what that means is we're going to need 1 s orbital and 2 p orbitals, and they're going to mix. So if this is energy going up like that, you're going to get 3 sp2 hybrid orbitals. Right. So there's your 1s orbital. There's only ever 1s orbital at any principal energy level. All right, now we're only mixing 2 of the p's. So this third p is just going to remain unchanged. Okay, so let's just redraw that. And I'll just label that again 2p for that 2p orbital. All right, so we have now we have 3 equal orbitals, and that therefore we can make bond angles of 120 because now they're 3 equal hybrid degenerate orbitals. All right, so that's what we need. By the way, let's put these electrons in here now. I'm going to put all 4 of these valence electrons into this 1, 2, 3, 4. All right, so there's our new. I'm not going to worry about the core electrons here. I'm not going to keep redrawing that. All right, so let's see what this looks like. Oh, by the way, if we were to see what this looks like, it's going to be 1 s orbital combining with 2 p orbitals. So it's going to look similar to the sp3 orbitals from before, just a little bit more s character. Okay, but I'm going to draw them pretty much the same, where one lobe is bigger than the other. All right, so I'm going to draw 3 of these, representing the central carbon on the left. All right, so there's 1 sp2 orbital, and here's another one, and here's my third one. So I just drew 3 sp2 orbitals, okay, 120 degrees apart. Now let's see how they're going to bond with a hydrogen, which has one electron in the 1s orbital. Let me label that. Okay, so this is going to pair with that. So I'll draw that over here. There's your hydrogen's s orbital. And so those are the two shared electrons there, overlapping. And I'll do another one here. 1s. Obviously, these electrons are going to be spinning opposite ways. I'm just drawing them all pointing up. All right, and then so that's going to be right here. All right, and then let me redraw one more. I'm going to draw the energy. I'm going to do this all over again for that central carbon over there. All right, just the valence sp2. 1, 2, 3, and there's my 2p unchanged. All right, so there's my 4 valence electrons for the carbon, central carbon on the right. All right, I'm just exactly the same thing there. All right, so let's draw these 3 sp2 orbitals. Okay, one is going to be head on, so that's called a sigma bond, right? Head on with that. All right, so I just covalently bonded those 2 sp2 orbitals from one carbon to the other carbon. Right? There's a carbon there, and there's a carbon there. All right, so I'm going to draw these other 2 now. Okay, there's 1, and there's 2. All right, and we're going to need 2 more hydrogens. All right, so this one is going to bond with air covalently and draw that down here. There's the 2 electrons, and there's our final hydrogen covalently bonding with. These atoms are not drawn to scale. All right. All right, so we're almost done. So now we have 120 degrees. There, 120 there, 120 there, 120, 120, 120. Now, and by the way, these are all sigma bonds. These are all sigma bonds because they're all bonded in the line head on. If you draw a line between the nuclei of these atoms, so nucleus there, nucleus there, the bond is in that line. These are all sigma bonds. All right, so we just made 1, 2, 3, 4, 5 sigma bonds. Right, so the last one is going to be this p orbital overlapping sideways. So see if you can visualize this. So this is all on one plane. Okay, so those 3 are all on one plane. But this p, that p orbital is perpendicular to that plane. It's like, all right, if this triangular plane here is going horizontally through your screen, this p orbital is going up and down on the screen. All right, so I'm going to draw that. All right, and then this p orbital here is like that. So these are going to overlap sideways and form what's called a what do you think? It's called a pi bond. All right, so these are not in the internuclear axes. So they're not sigma bonds, they're pi bonds. Anyway, there's an electron there, there's an electron here. It's actually that whole region. You know, I just picked the top one arbitrarily. All right, but they're overlapping. All right, so that's your double bond. So a double bond is always one sigma bond, which is the head-to-head overlap, and one pi bond. Okay, so let me actually label that. These are all, we'll label them all, but there's your sigma bonds, and there's your pi bonds. So I hope that helped here. Here's the thing to take away from this. Okay, if you need 3 effective pairs or electron domains, electron regions around the central atom, then you're going to require sp2 hybridization. All right, hope that helped visualizing this concept.